like the annoying neighbor.
Okay.
But tell me.
So let's say Nate. Nate's playing soccer. Okay? He moves toward the ball that's in the air, and he heads the ball while it's in the air.
Same moving.
The ball's speed and direction change after it is struck by Nate's head. The ball moves across the field with a different speed in a different direction than it was originally going. We can use all of our kinematics equations that we've been using up to this point, along with the force stuff that we've been doing up to this point, to come up with the momentum of the ball. Uh-huh.
Wait, so momentum is lower. Why?
Yes.
Is
That's what mega is. I agree. I agree. I think it's really cheese that they use.
Uh-huh.
Well, they can't use M because small m is math.
Okay.
Those two ends.
So, in this chapter, we are going to examine how forces and the duration of a collision between objects can affect an object's motion. Okay? I should do a pretty cool lab where a car hits and bounces off, and then there's an elastic collision where it hits and sticks.
Isn't that inelastic?
Oh, wait.
Inelastic.
Yes, sorry. Did I just speak? What did I say?
Elastic.
Yeah. I don't know how he remembers that either.
It was like, I can't remember. It was,
Huh?
no, wait.
So, momentum is defined as the mass times the velocity of an object. Okay? What's momentum? That's what happened. All right, open up your books. Turn to page 191, please. That's what I was.
That doesn't even sound good.
We got a biker here. And he appears to be going down a hill. Okay? Just everyone close your eyes. Close your eyes. Imagine.
That's actually the same.
Close your eyes, everybody.
Why do you have to open our book?
Good question. Okay, close your eyes. Okay? Imagine you're on a bike. You're coasting down a hill on a uniform slope. So that hill is got a perfectly uniform slope. Okay? You're moving down the hill, you're not pedaling, you're not using your brakes, you're just feeling the wind in your hair. Okay? Alright, yes. Because of gravity, you will accelerate. Which means your velocity is going to change over time. You're going to be speeding up. This is known as picking up speed or gathering momentum. You're gathering momentum as you're going down. Quiet. Okay? Then you open your eyes and see a sign in front of you. And you hit that sign very hard. Ah! Okay? The faster you move, the more momentum you have, and thus the more difficult it is to stop you. However, that sign applies a strong force and smash. This happened to me the other day. I was walking. No, I was fishing. And I was walking back with my buddy, and his fishing line got all tangled. So I'm watching him untangle his fishing line, and I walked right into a sign. Hit my head right here, just smack down in the sign and dropped me. I laid there and I said, physics hurts.
You did not.
Momentum stopped.
Actually, wow. So, was your actual thoughts live?
Yeah, my friend was laughing. No, actually, he felt really bad because it hurt real bad. I think I still have.
And falling backwards.
No, I don't. Anyways, okay. Now, imagine. So we said that momentum is really based on how massive the object is and how much velocity it has. And you can say the more momentum something has, the harder it is for that object to what? Stop.
Stop.
Okay? Alright? It's similar to inertia. The more inertia you have, the more you want to resist a change in motion. Very similar. Okay? So imagine you have a bowling ball and a little rubber ball. And you went bowling. Okay? Imagine using that little rubber ball to hit those pins down. Throw it real hard. What's so funny?
You know the average bowling pin weighs 3.3 pounds?
Oh yeah! You want to know what the average rubber ball weighs?
Does it have something to do with centimeters?
Okay?
It
So,
weighs 5 centimeters.
10, what I need to ask you guys is, hey, come on, is can the bowling ball and the rubber ball have the same momentum?
Yes.
One just be
How can they have the same momentum?
really
Rubber
slow
ball
like
is going
that.
faster than the throw ball and bubble.
Okay? You inject the rubber ball with more weight. No. Okay, the only way the rubber ball is going to have as much momentum as the bowling ball is if the bowling ball is going either really slow or the rubber ball is going
Extremely fast.
really fast.
Or both. With that fly, yeah.
Okay? Is it weird to think that the rubber ball, if it were going fast enough, would hurt more than the bowling ball at a certain speed?
Yes.
Yes.
Well, surface area is like a way different thing.
Now, you do have to take in consideration that the rubber ball probably has some elastic stretch to it, and the bowling ball doesn't. So there's that part of it too.
Wouldn't it technically hurt more because more pressure?
No, it wasn't the lab. It was just doing conservation of momentum, and there were 2 billiard balls. Billiard balls? Yep.
8 ball.
So, let's do it properly.
What? We're just jumping right in?
Jumping right in, y'all.
What is this? Momentum and force?
What about impulse? What's the point of something?
So we can envision the bike.
I had you look at the bike, and then you envisioned yourself on the bike.
That's why we don't do it.
Yes.
Hey, Kramer.
You're just looking for a reason to use this book.
Oh yeah, that's a different picture than I have.
I knew
You've
it.
met
It's
him?
not like saying this teacher meetings or something he's using the book.
Alright.
Visual aids.
They're
I'll slap you silly. You want me to start singing?
I slept.
No.
Yes! Utopia!
Utopia! Alright, we got a pickup truck. Out of a lot. Oh wow.
That's super easy.
Oops, can we skip that?
What?
No, this is a really easy problem.
56,000.
Wait.
Momentum and force.
No problem.
Gas, time, velocity, momentum.
Did I science right?
Wow, I cannot believe I made this really easy.
He's got to answer. I think the force.
Kramer, what's it measure?
Thank you, dude.
Guys,
Gold now.
your units, there is, believe it or not,
800.
your unit for this guy is not a derived unit. They don't give you a derived unit, so your momentum is 5.6 times 10 to the 4th kilograms times a meter per second. That's your unit for momentum.
What's in meters per second squared?
A newton is a kilogram times a meter per second squared.
Oh, it's like a Newton Jr.
Yeah, that's what that. It's a big newton.
No.
I don't think that.
Did you know that big news from our
I don't
game
think
after?
I believe it.
Wait. So we use whatever the problem has.
What party?
This will always be your momentum unit right now. Yep. It's just not like one unit. It's not like Newton, even though that's a derived unit. Does that make sense?
Yes.
I don't know why they don't have a derived unit for this, but they have a derived unit for everything else. Probably the same people who came up with the fact that momentum symbol is P. It's actually a Greek symbol, rho.
Roll your
Rho.
boat.
Yeah, the street.
Merrily,
You guys hurt my brain. Okay?
Momentum.
Now, momentum is a vector quantity. Write that in somewhere. If it isn't in there somewhere, that's everybody.
It's right here.
Actually,
Is it?
the fact that work was
So, I should say that it has this much momentum to the...
Direction he was moving.
Why did you say east? He's
No,
not,
stop.
he never says he's going east.
It
It
literally
says
says in
right
the
here
question,
to the
then
east.
Oh, I didn't see that part. I just skipped that word.
Yep, that's gonna be 9 on the quiz.
Well, you're speaking to the underdog.
Kind of close.
Oh. Okay? Hard question? Alright, anything we've learned that it's a vector quantity, we've learned the units of it.
Oh,
That's about it.
Wait,
You doing
nice
alright,
question.
Henry?
What?
You doing alright?
How would the units not be kilograms times meters per second every time?
it is always time.
So it is a derived unit.
No, a
No,
derived
right, like
unit
it's just one.
Derived is like kilograms times meter per second squared. The derived unit would be meters.
Oh,
That's the
Like,
derived.
there's no.
Or like
key
it's like
number.
saying like, hey, a kilogram times meter per second is now a like apple
This
box.
would be the underived unit. So this
Okay,
is
so
an
it's-
underived
so its
power.
thing is always kilograms times meters.
Yes.
So what's the change in size?
This way.
You have to solve for. You do this
I
like
just
for you
switched
do
back
the impulse.
I mean, I could.
I don't know, I could just put it in here. It's probably a good thing for the future. You're helping me out.
You know, I'm pretty sure I would learn better if I could like.
Why would that?
Because I'm always underneath
It's
the
so
blanket.
sad because like
Why? I am a blanket. I am never underneath a blanket.
Like even in the summer, I'll pull it on.
Oh yeah. Well, I mean, I can't sleep without a blanket.
No, like even just sitting downstairs.
Why? Like it's 80 degrees.
I think it's a comfort
You need a pacifier too?
You know, I had a pacifier until I was like 5.
oh my goodness, cold.
Such a cutie.
That is so cute.
Yeah. I had like a little strap and everything.
How many centimeters was it?
Not even French now.
Oh, wait,
How many centimeters was it?
There's so much hate in this room.
You deserve
Sarcastic
so
hate.
much.
I'm happy. I got 100. I don't know.
I just saw it.
Ah!
No, not the Lego
It's
bird.
Adobe Flash.
Oh, Legos.
I know how to do it.
Alright, move on. Okay, here we go.
What the heck? No, that's
Here we
not.
go. Impulse.
Impulse and flash.
Honestly, I think this equation did more for me than any other equation in all of physics.
What does that mean? It impacted you.
It explains so much for me.
Force times.
If you can figure out the time of collision for a specific force that wants to stop an object from moving.
That's so cool, man.
You can also you can figure out why in the world you jump on a trampoline, it doesn't hurt that much, but when you jump off a trampoline, it hurts a lot.
Trampolines.
They got no squishy boy.
No, because the time of collision on a trampoline is larger, so the force is actually much smaller.
Oh, great.
Did everybody hear what I just said?
No.
When you jump from a trampoline off the trampoline, it hurts.
Wait, when you hit something?
When you hit the ground, you jump from off the trampoline. Like if you were to jump on a trampoline and then just jump off,
Oh.
it hurts. I've done it. It hurts a lot.
So what's the alternative?
Okay? Just jumping on the trampoline. You're jumping from the same height for the most part. The only difference is you're adding maybe this much distance between the ground. Okay? And it doesn't hurt at all when you jump on a trampoline, and the reason why is because your change in momentum is virtually the same for both situations, but your collision is much higher time of collision on a trampoline. Therefore, your force when you're on a trampoline is much smaller. Therefore, it doesn't hurt as much. Yes.
But when you jump onto the ground, you like stay on the ground.
Your time of
Yes,
collision
you got
to
it.
get you to stop.
Also,
The time to get you to stop is
Oh.
instantaneous.
Oh,
Versus the time to get you to stop on a trampoline is not instantaneous. It's over a time frame.
Oh, so
But it's a squishy boy.
Well, that's the result of why it's the way that it is. Yes. But imagine you have to get your momentum to stop. You have to apply a force. But if you do it over a time frame, you can do it you have less force over a longer time.
So it's because when you're landing on the trampoline, it's bending down.
And it's applying a force, less force over a longer time versus jumping off onto the ground. It's all that force at once to stop you in a split second.
That's pretty cool.
Also, is my trampoline like elastic?
But
That's why.
just because you say that, he doesn't disagree with what I'm saying.
No, I wasn't even there.
What?
I don't know, it's just
Anyway, it's weird to think about. Okay? So, So your impulse, if I ever ask for the impulse, it's your force times your time is what your impulse is.
And time is how long it took you to stop moving.
Yeah, it's your time of collision.
But yeah, that also equals to the momentum.
Okay, yep. So impulse you could also say is your change in momentum. Okay, so the impulse momentum theorem states that when a net force is applied to an object over a certain time interval, the force will cause a change in the object's momentum. Okay? And you could find a change in momentum that wasn't like the full change to a stop, but we won't do that. Okay? Let's apply problem.
Is there a lab this chapter?
Yeah, that's a fun one.
I know, is it the one that
I
is
checked.
tomorrow, Steven, the one that hurts?
No, it's a, no.
Oh,
He was just referring to a dumb thing I said in a previous class.
oh.
Yeah.
Previous year,
I got
first
this.
year.
I got this one straight.
Alright. Here we go. We got a 1,400 kilogram car. What else do we know?
Time.
Okay,
Velocity also.
what is the time?
VI 15.
VI is not 15.
It is negative 15.
Yes.
Roll back.
Ah, I
Wait.
hate scale. I hate vector.
Why is it negative?
Oh, because it's moving less.
Oh, so then my answer. Oh, we can just put negative.
Yeah,
We
we
just
do that
pick what's
at
at
the
the end.
Yeah, I did it at the end, so I'm.
Yeah. So I'm a late. I'm a later on.
You'll actually find that the force is not west.
Oh, it's the opposite of what you say. This is what you do for guys.
Okay? So
That's smart.
let me show you. Okay?
Is VF 0?
Wow,
Yeah, it is
genius.
0 because it comes to
VF?
rest. It's brought to rest.
V? Oh, V.
Wouldn't
yeah.
VF always be 0 for solving for like the
No,
time
I
it takes
accept
to
it.
stop?
If you were to talk to the
Yeah.
time it takes to stop, yes. 0 meters per second. Is there anything else here that's pertinent to this problem?
9.81 meters per second squared.
But it's not used here.
Yeah, but gravity's always.
Gravity's everywhere.
Gravity's in space. Change in P, but we know change in P is really MVF minus
So
MVI.
negative MVI, which is also just positive.
Which is why you have a positive
So
force.
you forgot the force. Oh wow, that's cool.
So the amount of force that, what is this, a car? I'm assuming it's the brakes, or is it a?
It's in the sign.
But it's force.
Why did the utility pole?
Oh, yeah, the force that the utility pole applies on the car. Or if you're KJ, it's a,
What did KJ do?
it's
The mailbox?
just a mailbox.
He did a mailbox?
Yeah.
Oh yeah!
Right out here.
Yeah.
Yeah, or over that way actually.
Yeah, he's texting it.
So we have a final velocity that's 0, so can I get rid of that whole part of this? Okay, so it'll be negative MVI over change in T.
So is it F?
So then I will just plug in here my force. We got a negative 1,400 times negative 15 divided by 0.3 seconds.
Couldn't you just take the absolute value of the force if you were to do without?
You're not looking for the genius.
Okay? When you do this, you should get a pretty large force.
70,000
And we need to apply a direction because we know Newton is a vector quantity.
Wait, why isn't it kilograms times 0?
Newton's a vector quantity.
That's what a Newton is.
I know, but you said that it's not the drive force.
That was for momentum. This is for force.
Isn't it technically E?
Okay,
Momentum is a non-derived unit. Force is a derived unit.
okay.
Are you talking about?
I understand it.
Are you talking about
Momentum of your relationship status.
Yeah.
Going downward.
It's actually.
Oh, it's negative. Literally stagnated at negative 4.
Steven, it's yours too.
I'm pretty good in words he
I
can
was
understand.
referring to his. No.
I'm pretty good in words he can
This
understand.
is past you.
Sorry, I just thought.
Why is it east?
Whoa.
Why is it east?
Because you're west and you have to have an opposite force.
If you had a force in the direction of motion, would it stop?
No!
Just like how you were talking about.
Well then guys, these negatives cancel out, which means it has to be some positive direction force. Now, from the context of the problem, it's not going to be a north force. Right? It has to be...
Technically, I had it right. That's it. Negative 7.0 west.
What?
If you didn't do negative at the beginning by putting the 15 negative, would you put negative 70?
Stop.
That force just hit you all over. Therefore.
Alright,
It's the version of it.
So true. I know.
Big number, positive. What was that? This is a number bigger than 1, so if you're going to make it scientific notation, you
Would you like me to explain the science of
it has
Hey,
to
could
be
you explain to me
a
why I got
positive
70 wrong?
It's a positive.
Because you're a dumb boy.
No, but I was a little slow. Negative exponent being smaller than 1 or in the decimal.
Therefore, you scratch hit the ground. The force is it's a lot harder, and you have less time to understand what happened. Therefore, you just go straight.
And then you just go straight to no.
You just go straight to something that's stupid or something. He's not loving her anymore.
I'm screaming.
All vibrations?
Yes.
especially according to Jonathan. Okay, you're Jonathan.
Did he say that? I know that kid. And it was so funny.
What? You know Jonathan?
Oh yeah. Okay, so weird.
So we had this assignment in college comp where we had to like write a paragraph about our favorite genre. And that's like wrote this paragraph and like Mensch said his favorite genre is country. And said his favorite song was like Beautiful. And Jonathan was like commenting on his paragraph. He's like, and like the next day he responded again. He's like,
Emma! He's like, you should come chat with me after school.
Challenge him.
Gone fishing?
Friday. You're like, he's like, I don't understand how tomorrow, next year, some of the lyrics to prove how bad this song is. He started like quoting the lyrics. Not that bad. It's like, I was so bored. I was ahead. I was so everyone is like, these are all the words I was taking this off of my YouTube. But I just
It's actually quite a good song.
I haven't heard it, but I'm sure it's very good. Yeah. I have a question.
What is life? Baby, don't hurt me. Don't hurt me no more. What is life? Baby, don't hurt me.
Do you have my case grade? You don't have to show me the test, just like what did I get? Because I've been looking online.
Write fearlessly. Come on.
Hey, I got my stuff. I don't have any. Okay, we'll turn it in, then I'll erase it.
I have a question on you.
So I filled this out, but I don't know the detail. So can we have you do them? Do that like today? Next week you go to Tuesday and I can Monday. Oh, snap. Something wrong?
Well, I have to get this assignment's done before I go.
I don't have to.
Where are you going? Alright, can I have my pen?
I doesn't have.
All right, let's chit chat since I have a feeling there might be a few questions I don't know what.
Right here. I like doing the doc notation.
What?
I like doing the doc notation. Oh, I forgot that.
He did. Wait, what did he see?
Or
I have a pen.
have it high.
We do good
No.
with this, and we're a small bit of
What?
we'll be, I can fix
Peaceful
that.
risk?
Lucky.
Bro. One word.
Shane.
I did better than I thought I did. Man.
Oh, you should have just guessed. Oh, you didn't
what?
fill in.
Oh, but it's probably better wrong, no?
Yeah, but
10,
what
yeah,
if you?
10, I put SB, but it was SG. FB was what? Phosphorus? What is that?
Wait,
Oh,
FB.
Oh, that's iron.
Why did I put HE?
Where
That's
did I put
helium.
iron at? Oh. Yeah, you got it right here.
What the heck?
Oh, look at me, I'm just a big idiot.
Where's Moira? Where's
You
Rose?
need this back.
We're still getting stuff. Stupid mistake.
Oh my gosh, I got
Oh,
so
I
much
didn't
better
even
than
give you
what I
a
thought it
sticker.
did.
Hey, Kramer.
One,
So we got-
four.
This was happening with this one, right? So, I put yesterday.
Oh.
What? Well, it's still A plus.
That's not.
Ow.
Why? Wait, we can see this. I got this and I was trying to figure it out. No, I said it in
Just put it
7 hour, I think.
Figure it out.
Why? What's wrong with this now?
I didn't do it. I had somebody help me.
Oh.
So.
Dang.
Have a rib.
Oh, thank you. You're welcome.
Moira.
Guys, I forgot to do the
I have it
flash
too.
cards because you get like 12 points.
We're still
That's not true.
12 points.
4.
Like 4?
Wait.
Yeah, it's every 6.
Four is the
Yeah, I
last.
think it was every 2.
Four is the
Still.
Every 2. Holy gracious.
Can I say?
Can I turn these in?
Do I have what?
Magnesium.
Not really. Why?
What do you
What are you for?
I used to sound like that. I think I said it.
Oh, I.
And she
Alright.
did mine last night.
I did ask him, okay, that was the only one.
Alright, here we go. Number 1.
Wait, I'm not ready. Oh, we're not ready.
Let's go through them. Number 1. Magnesium. Lead. Iron. Iodine.
Dang it.
Hydrogen. Helium. A, you stole my gold. Fluorine. See you at the copper mine. Chlorine. Carbon. Calcium. Bromine. Put them in the ground and bury them. I had a chemistry joke, but they're argon.
I
Aluminum.
got that. Say that again? I had a chemistry joke, but they're argon.
I was gonna tell you a chemistry joke, but they're argon. Zinc. Zn. U. Sn. S. Nah. Ag. Don't watch over. Si. K. Capon. Kpon. Nickel. Ni. Neon. Me. Mercury. Hg.
H? You said H?
Hg.
It sounds like you're saying H.
H.
Yeah, he did sing. The letter H, the letter G.
Like holy H.
Like hug without the U.
I just realized
I thought it was
H
A.
is spelled like ACH.
I thought, when I was younger, I thought the letters were all spelled like A. Like B with B, B, E, E. Yeah. But I was like, but then I tried to think, well, how can you spell them without using the letter? Oh wait, can I take my sticker off? I wanted to keep it.
Thank you.
What's the matter?
I wanted to keep our sticker.
Wanted to keep the
Did you
sticker?
get less than 100?
I'm not gonna be able to get that off.
Well, you didn't get 100 either, so I don't know
I'm
why
not
you're
better
saying.
than I thought I was gonna get. That's a good thing.
Anybody else want to keep your sticker?
I'm gonna put it right on my book. That's probably not gonna go
Oh.
off. I don't think we get these back.
Hey, Kramer.
Why?
Hey, Kramer.
You want to frame it?
Hey, Kramer.
Make it again. Machine or science or
Seriously, woman, bring your own snack.
Yeah, bring your own snack.
Alrighty. Homework, are there any questions? I assume so.
Kramer,
Yeah?
I'm not having a good day. Can you let me off the hook?
Can I let you what?
Off the hook?
Off the hook?
Just let that one answer pass.
Right, I'll let you off the hook. I'll take the hook out. Alright, stop.
You know what's a terrible feeling?
Take the Fruit Loops and leave.
Take a Uber and leave your lunchbox.
Oh, yeah, that is.
You run Uber?
Yeah.
Uber deal.
I don't.
Super Uber deal. Wait, so do you sit in the backseat?
Yeah.
What was it?
Just fine.
Questions on homework.
Not that I know of.
What page?
Number 6 was slightly easier.
Okay.
Good for you.
Well, I couldn't tell if it was gonna be the one or the other.
Wait, what did you? But no,
I
but
put C.
I put CCM as well.
Because it's
Who
not.
put that? Because I looked on the thing and it said that francium and the other one is radioactive.
The largest non-radioactive element
I think.
is cesium.
Yay! Yay!
What? It's
Okay.
So,
I thought it was francium. Francium is radioactive. Oh,
How would you know it's radioactive?
because it
There's
has
a
the
in the
little
book.
it has the little fitness spinner in the corner.
Yeah,
Right.
and it says radioactive.
That's why those guys just blow up the francium.
Oh. Now I understand.
Yeah. Remember that video that we watched that Jane never got to watch?
Oh, and
They couldn't use francium because it's radioactive, my friends.
Well, what happened?
And also,
Did you guys get 4 and 5? I'm not sure you guys are good on
Just
that.
read off the answers.
Yeah. Is it just putting them in order?
I'll read off A for 5 and for 4. How about that? Number 4, BEMGBA.
That's what I got.
That's what I originally had, but then I changed it.
I'm
because I
right
was
on that
wrong.
one.
5,
Take it back.
5A, HLIK.
That's what I got. Good job, Kramer. You
Yeah.
got it right.
You're
Anybody want to go over this?
No,
Shane, yes.
Rose
You?
might. No, Rose doesn't.
Also two.
I wish there was an M on the periodic table.
Wait, what are those names?
Is that-
There's so many words in that.
Yeah, and there's no A. I thought there was an A.
There's AL, but that one's in.
Yeah, and B was next to.
There's no Z except for zinc, and it's not on, or a Z.
All right. So let's focus here because I just want to quickly review how this all works. Okay? It says metallic character, conductivity, and the size of the atom. All these things decrease as I go across, which would be left to right on the periodic table, and increase going down, or I would say from top to bottom. So let's see. Let's do 4B. It has BRCOGE.
Dang it, I got it wrong. Kramer.
BRCOGE.
Oh,
Okay, that's not the order.
okay.
That's just what they gave in the problem. Okay, so let's find them. Bromine,
And then it was right over there.
cobalt, and germanium. They're all in the same horizontal row. What do we call the horizontal rows? Periods or series, and they tell you what?
The
How many valence electrons?
The energy levels.
The energy level.
Okay? But as we go from left to right, we have a trend. The trend says that as I go from left to right, the character, the metallic character, the conductivity, and the size all decrease. Now, in this problem, what are they asking for? Size?
Yeah, increasativity.
Place the elements in the following order of increasing conductivity, okay? So it says from left to right, the conductivity decreases, so then from right to left, the conductivity would increase. Okay? So, bromine would have the least conductivity, followed then by germanium, and the most conductive of that group is cobalt. And it should make sense because cobalt is the most like a metal, and we know metals conduct heat and electricity really well, don't they?
Yes,
Make sense?
yes.
You have questions?
Is it as in order going up in conductivity?
Yeah, it says increasing. Yeah, so you would start with your least, and you would end with your increase, your highest. Order for B is gonna be bromine, germanium, cobalt.
Okay, I got it right. Good job.
You went decreasing order. So you always read left to right. So when you write, if you want to be increasing, your furthest left should be your smallest, so that as you read left to right, you're increasing. That make sense, everybody?
Yes.
Shay, does that make sense?
Yeah.
Any other questions here? I want to go through one more. Are we Gucci?
I got
Oh,
all
my
of it.
What's that?
I hope I'm right.
What?
I hope I'm right now, because I just checked it 5 times now.
One more or what?
No.
Two? Number 2, you have a question on? How does the number of main energy levels in an atom generally affect how tightly its valence electrons are held by the nucleus? Okay. Anyone think they know?
For which one?
Number 2, go ahead.
The more energy levels as bigger it is, and the looser the
The looser
bonds are.
the electrons are held. So like if I had my Bohr's model up here, right? Energy levels get bigger and bigger and bigger. And so your electrons get further and further and further away from the what? The nucleus. The further you are away from the magnet of the atom, the looser it's going to be held. Looser, more loosely. Loose? I don't know.
We're just going over stuff like that.
Yeah, but we have to.
Yeah.
Ask him. Ask her. Her? Yeah.
What's that hard? What are we talking about? Not hard.
Say, would you say more loosely or would you say looser? It's looser.
I would say.
It's looselier.
It's a lot less
How
tight.
is Louis?
Yes, it's a lot less tight. It's not as tight. It's more loose. Okay? Questions? Any others?
No.
All right, muchachos. Oh,
I was gonna ask you the true or false. It's either true or false. I don't care if I have a 50-50 chance.
Is it
I would
number
like to
7?
understand it, yes.
since oxygen and fluorine atoms are relatively small and lack only a few valence electrons to complete their octet, their atoms attract and strongly hold electrons. The answer is absolutely true.
Yes.
Okay.
It's funny how you just do this.
No, it's not funny, it's great.
It's awesome. I mean, it's sauce and sauce.
Do you want me to not just give you the answer?
No,
No, I don't care, I'm just saying, I didn't know.
Mr. Fincham was like, just trade in your homework.
Now listen.
I kind of understand it.
Well, I'm assuming you guys actually attempt it. If you guys don't attempt it, your quiz and grade scores will show this. Like if you guys just don't try and then ask me questions and have me just give you answers, you're probably not going to be very successful on a quiz or a test.
Yeah, and that's your fault, so.
Yeah. So, there's an aspect of your own learning that you have to take responsibility over. So that's kind of life. You have a question, or you just? You guys understand why? If you've got electrons really close to the nucleus and it only wants a couple more to be stable, it's going to have a strong attraction or a strong desire for electrons. If it only needs one to be stable, for example, halogens, they have 7 valence electrons, right? An octet is 8, so it only needs to gain 1. It's going to have a pretty strong desire for that 1 electron. The reason why is because it's got a really small radius or size of the atom that its protons in the middle are going to attract any lingering electrons to itself. Is that it? Can I now shut my book with peace and comfort?
Wait, so we're not going over.
Design a dating website
Yeah,
for
so they
electrons.
can get their perfect match. Oh my goodness.
Hey,
Stop.
parents, I got a question. So the test is tomorrow.
Uh-huh.
And they all
What we were
agree
doing
on it.
today?
Uh-huh.
And their relationships are all stable.
No book. What'd you say? I totally missed that.
And their relationships would all be stable.
But some are more stable than others.
Yeah.
And some are more attractive than others.
Yeah.
Explosive.
Yeah.
This is why this needs to be a thing. Oh,
Derek,
dark.
To the rock.
how am I supposed to know that?
You didn't
I'm
trust
just
me.
supposed to trust you?
Did he go to
Yeah, you
the
can-
gym yesterday?
Can I trust you?
Yes.
The one who has 2 missing assignments? Okay, do you have those other ones done? Alright, if they're not turned in before the test, you know what they're worth. Right? You know what they're worth if you don't turn them in before the test, right? We don't want that. I don't want that. You don't want that. God doesn't want that.
Fair and false.
Wait, so is that, do you get any points off for turning it in late?
Yes.
What is it?
Depends on how late.
Oh, in middle school, it was just automatically 25% off. So even if you got everything all right, the highest you could get.
I mean, if you're gone, you get 3 days to make it up. Or something pretty like that. Alright. Y'all ready? Let's review.
Wait, remember, can you remind me,
Yes, I would love to erase
Disclaimer.
diligent students.
We must send out a disclaimer, you will have a lot of fun in this science.
Alright, so we Kahoot?
Yes, you should.
Can I have a thing? Oh my gosh, I'm so glad. I need to try.
Hold up. What?
Watch out.
Yes.
Really bad busy.
Wait,
Probably can you go erase that middle board part of
I will.
Please.
No, y'all always do it wrong, man.
My data
No, you're gonna take forever.
No, don't do that. No.
See, I told you they always do it wrong.
What? I don't have a device.
You don't have a device.
Yeah, me neither.
I have a.
Yeah, same. I have a Chromebook too in my locker if they want to use that.
Yes, please.
Okay.
Yes, please. That would be very helpful. Thank you.
Ever, do you want to use one?
Is this on?
Probably. Darn it. Can you shut up?
Kamari's in it. It's been going for 41 minutes. Do you just shut it?
No.
Oh.
Just a little button right here.